This is Diseño sacaiensis. It's a new species of bacteria, and it can do something that no creature has done before. It can eat plastic. It's evolved a unique enzyme called PETase, which turns garbage into food. And if you've been paying attention, you'll know that's a pretty big deal. Plastics are polymers, long carbon-based molecules that don't biodegrade. We've produced over 8 billion tons of this stuff since its invention. We dump it into landfills, rivers and oceans. We eat and drink thousands of microparticles every day. Every year we produce another 300 million tons. Barely 20% is recycled. With the world drowning in plastic and no end in sight, maybe it's time to turn to nature, which has solved this problem once before. Trees, like plastics, are made of polymers. Even though bacteria and fungi can decompose trees today, some scientists think it took them 60 million years to learn how. In the meantime, dead trees littered the earth without decomposing, slowly compressing into the coal that we burn today. Diseño sacaiensis is the first of nature's new cleanup crew, here to deal with our plastic mess. The problem is, it's not very efficient. It can take weeks to degrade one bottle. And that's why some scientists want to lend nature a hand by accelerating evolution.
Synthetic biology is really the attempt to harness that massive diversity of microbial life and then engineer them to be able to do things from an industrial perspective that will still harness the selectivity and power of biology.
In fact, they only intended to test how the enzyme worked, but with just a small change accidentally made a stronger mutant enzyme. But this was just the start. Decomposing a tree takes decades, and plastics are even tougher, so supercharging plastic-eating bacteria will take every trick in the book. The first is selective breeding. In the same way we breed prize racehorses, researchers are choosing the best bacteria and allowing them to reproduce to create the next generation of super eaters. Second is directed evolution, a technique that introduces random mutations to enzymes, allowing for researchers to yet again select the most successful ones. Third, using supercomputers, they can redesign the enzyme itself, calculating how to make it more efficient and effective. And finally, they are genetically modifying other bacteria to produce that PETase enzyme. For instance, PETase works better in heat, so scientists are engineering it into bacteria that can survive in Yellowstone's hot springs. The goal of all of this is to trigger a recycling revolution. Virgin unrecycled plastic is often cheaper than recycled plastic, and plastic can only be recycled a finite number of times. Plastic-eating bacteria could be the solution to both of these problems.
And we can engineer the microbes to spit something out and produce something that is higher value than what the food they start with. We for example, can convert waste water bottles into high-strength composites that you can use, for example, in a wind turbine blade or in a surfboard or a snowboard. Those plastics have much, much higher value than the plastics in water bottles. The ultimate goal here is to enable plastics upcycling technologies, which will then incentivize the reclamation of waste plastics around the world.
The implications of this could be enormous. Landfills and floating garbage patches could become gold mines, which means that cleaning the planet will make financial and moral sense. And that's when real change happens. But you might be wondering, why not just release these mutant bacteria into the wild? Perhaps they'd multiply across the world, consuming the plastic in our landfills, rivers and oceans. Or maybe they'd go rogue and start eating the plastics that we depend on.
Most genetically engineered organisms are pretty wimpy when it comes to actually life in outside of a lab, outside of a sterile, pristine bioreactor, where they're the only game in town. And so I think there's very, very low likelihoods of problems with these things.
We can't wait for a silver bullet to solve our plastic problems. Reducing and reusing will continue, but bacteria may one day become one of our most effective weapons in the war on plastic waste.